You know, sometimes, I mean, it happens so much in life that all we are is bombarded with numbers. In fact, it doesn't only happen in math, it happens even more in life. You're bombarded with mathematical values. And in fact, they're typically not even organized. They're just jumbled up, thrown in your face, and so confusing they spin your head around and throw pops off. Right? That's really what happens. I hope that never happens. But in math, what we can do, and also in real life, is we can take these values and actually organize them, put them in lists, sequences, and actually make them make sense. We can make sense of our world by cutting it up into smaller pieces and just reorganizing, structuring. So what we're going to do is take a list of numbers here. Oh, I don't know. Let's take this list here. Um, All right. So what we're going to do is take a look at, let's say that I'm given a problem that these employees of a computer company system, uh, they have an estimated driving distance from work. And that driving distance varies from person to person. So these are going to be the different distances that are given. Ooh, cool, pink. Okay, so these distances will vary from person to person. Charlotte, I want you to move back here and sit behind Sean, please. Right here, bring all your stuff. This is your new seat. So these distances vary from person to person, and what we're going to do is just take a look at what those are. David, turn and face the front. This is the distance, and the values that I'm given here are, let me actually type them in because it'll be a little bit more clear. Let's say they are 10, 30, 45. These values are a little bit bigger than what I wanted, so I'll decrease the size here. Cool. 45, and let's say, 20, 15, 10, 10, 20, 15, 40, 30, 35, 20, 15, 10, and I don't know, 5. 5 would work out. What's up, dude?
What's the units?
Distance, what do you think? Think they're walking in inches?
Well,
It depends, man. I don't know. Maybe these are ants and they live millimeters away from that place. I don't know. I'm just kidding with you, Elliot. It could probably most likely be miles or kilometers, right?
right.
Right, dude? Dude, if ants lived that far away, it would take them 3 years to walk that far. Okay. Back on here, buddy. Back on track. Ants are like the coolest thing, by the way. If you guys want to ever do research in college, write an interesting essay, pick up a book on ants or bees. They make these complex networks of things. It's so crazy, guys. I'll let you do the studies. But here's what we want to do. I'm going to create another box because look at this. Just like in real life, guys, I was just talking to you. This is just a list of numbers. It doesn't really make sense. And Elliot even made a great point. What do all these numbers really mean? Well, I could say miles, but that still does not make that much sense. But what I want to do is I'm going to create what we call a line plot, guys. And this line plot, if I draw across here, I'm going to say, hey, do my arrows, and I don't know. Let's just go up in increments of 5. So I'm going to go 5 and 10, 15. I know you guys are probably saying, where's that wacky 0, Mr. Gillespie? Doesn't show. 30, 25. 30, 35. Okay, and that's a 30 right here. Okay, so my line plot, what it's telling me, guys, is I need to do 2 things before I can actually create the line plot. I've got it listed here, but I got to create a second box and just take this information and reorganize it, restructure it. So we'll go here and get my pen back. So divide this up, and I'm going to just create some different lines here, guys. let's see. 1, 2, 3, 4, 5, 6. Oh, don't want to do that. Let's see if these values will work. So this first value in here, I'm going to change color so we can see what I'm writing. I'm going to call it the distance up top. I'm just going to put a big D for distance. And the second value here, I'm going to do frequency because I want to know the number of times each value occurs. So if I'm talking about distance, so let's just go in increments of 5 again. So I'll say 5, 10, 15, 20, 25. Make sure you're writing notes, guys. 30, 35. And I'm going to stop at 40. That looked like a 9, so let's just turn that back into a 40. Okay. And the frequency, what I'm going to do is go through this jumbled list and just count them out. Let's mark them off. Well, 5 occurs 1 time. So my frequency for 5 is 1. And 10, well, 10 occurs, it looks like 1. Yes, ma'am, Charlotte. 2, 3. Well, Charlotte, if you were sitting up front still, you probably wouldn't have that problem. So this is 4. And now let's move on to 15. So 15, we're going to say, hey, 15 occurs at about, let's see, 1, 2, and 3 times it looks like. 2, 3 times.
Is that a 1?
Where?
She can't see anything.
This is a 1. This frequency, I'll scribble it out because it looks like a jumble. Charlotte, you should be taking notes. So 4, Charlotte, if you argue back, we're going to have a conversation after class. So 25 is going to, well, 20, our next section is 20, so let's count all the 20s up. 1, 2, 3 20s. We got 3 20s and 25. Well, I have, it looks like 0 20s. 25s, I mean, 0 25s. 30. I got 2. And then for 35, 40, and 45, guys, those all, I only have 1 of each. The frequency is 1 for each of those. So I'm crossing all of my values out now. 35, 40, and I actually forgot to put 45 in here, so I'll put it up at top. And 45 will be my last value, and it occurs 1 time as well. Okay. So from 5 all the way up to 45, the values are 1 for 5, 4, the frequency for 10 is 4, and so on. But what I want to do from this list right here, what I want to do, say, hey, nice. I'm going to put X's along my line 1. Okay? So let's start with the 5s. 5 occurs 1 time. What I'm going to do here, say, hey, 5 occurs once. Put 1x here. And 10, well, I have 4 10s, so I'm going to put 4 x's down. 1, 2, 3, 4. Those are real sloppy. I'm going to fix all of those. But there's 4 x's right here. And then again, for the 15, I have 3. 1, 2, 3. And then for 20, I also have 3. This occurs 3 times. 1, 2, 3. And then for 25, looks like I've got 0, so I'm going to skip 25. And then for 30, I have 2. I'm going to mark this twice. And if you look on my line here, you notice that I run out of room, so I can fix that real easy. I'm just going to grab an eraser. And I'm going to fix my line. Because it extends out to 45. Yes, sir, Isaac.
Didn't we like skip the graph and cross it out and put an X while it's crossing it out?
Say what?
Like instead of like going to control and making a graph, we cross it out and like put an X after you cross it out there. Go down.
What did you say?
Like personality.
I am so confused at what you're saying. Can you walk up and show me what you're talking about? I'm going to keep working with these, all right? So 30, we got 2. 35, I've got 1. 40, I've got 1. 45, I've got 1. What's up, dude?
So can you like just like cross out the 10 and like put next to it, like instead of going
You could, but what I'm showing you here is that there are different ways to visualize what you're doing. There's not just one way, right? That's a great question. So Isaac, I think everybody understood, but what he's saying here is, hey, why not just jump all the way down here? Why create a whole table or chart? Because there's different ways to visualize, create, organize, structure, and find one relation and two meaning. So there are different ways to find it. And what you guys have got to do, you got to do it. You got to make both. If the test says, hey, create a table, create a table. But that's a great question. Because now I've got two different ways. And Isaac, you want to know something? To be honest, for me, this table doesn't mean much to me. Look up here, buddy. Doesn't mean much to me, and it probably doesn't mean much to some other people. But some people, the way that they visualize are through tables. They really understand what this means right here. However, for me, like I said, it just looks like an organized mess of this. It's just from least to greatest, right? So, but when we get down to this chart down below, it really starts to make sense because you can start to see that most people in this company or most ants live between 10 to 20 miles away from their work, whereas everybody else, I mean, there's not many people who live more than 25 miles outside of their work. There's not many people who live 5 or 10 or less than 10 miles, right? So you really see the chunk of the workers, employees live within this distance of their work. Pretty neat stuff. That's cool stuff. And just different ways to organize and visualize data. Let's move on to another one here. Hey guys, based off of a stem and leaf plot, that's what we'll be working with here. Let's say that I've got a stem and leaf plot, and basically what I have here, Charlotte, for your sake, I'm going to be such a nice guy, because you'll see in a second when you say, Mr. Gillespie, you're probably the nicest person I've ever met. Wow, look how large that is. Okay. So this is our stem and leaf plot, and the values that I have for my stem and leaf plot, well, I have, let's say, a 0, 1, 2, 3 here. And then on the right-hand side, I've got a 2 and a 5 and a 3, let's say a 3, a 7, and an 8. Let's say a 0, a 2, a 6, a 1, and a 7. Yes, ma'am.
are we just like learning about different types?
We're learning about, yeah, visualizing or organizing data in different ways.
It's like a 1-day thing or like
It's going to be a 2-day thing. We're going to have 2 days on this.
we're gonna have like a test on it?
Huh?
We're having a test on it?
Yeah, in fact, I was going to give y'all homework on this tonight, but I think I'm only going to give y'all about 3 problems for homework tonight. Make it real simple, and we'll take this to a 2-day lesson. So moving forward with this, hey guys, this is what we call the stem. And the stem is my first digit. And this is what I call my leaves. So these are my leaves. These are my stems. I'll put an S to make it plural. Leaves. And what happens here is, hey, I've got my 0s, my 1s, my 2s. These are most likely digits. Well, actually, they are tens digits or tens values. The stems are. And these are, the leaves are the second digit. So what I would read this as, the 1 in this 3 right here, guys, would actually be, well, 13. And down here for the 3 and the 1, well, that would actually be 31. So let's go out, and I'm going to reorganize this as a list of numbers off of this stem and leaf. And so 0, 2 would actually be the value 2, and 0, 5 is 5. Well, we've already said 1 and 3 is 13, and another 1 and 3 would be 13. Then I'd have 1 and 7 is 17. 1 and 8 is 18. 2 and 0 is 20. 2 and 2, 22. 2 and 6, 26. 3 and 1, 31. And finally, 3 and 7, 37. So these are my values for the stem and leaf plot, and that's how I read it. Well, how would I create a stem and leaf plot based off of data? And actually, maybe we'll do a back-to-back stem and leaf plot. Now, let's do that. And no, I'm going to save that for tomorrow. That's a big one. But let's just create a stem and leaf plot based off of data that's given to you. So here's what I have. These are going to be the values that I'm given. How much time do we have on the board? 5 minutes. This can be done. So this is going to be the set of digit values that I've given. So let's say that I have 57, 65, 89, 74, 57, 68, 82, 84, 77, 70, 63, 85, 76, 68. No, I'm going to show you how to do it real quick. 76, 68, and 39. I can, yes. So here's what you would do. To create the stem and leaf plot, all you got to do is create the stem and leaf columns. You know how to do that. You got your stems. You have your leaves. Now, I see that I have my significant digit is the tens. My significant digit is 50s, 60s, 70s, 80s. I've got a 30s down there, so they're my tens. Well, it looks like my smallest significant figures are 39, so I'm going to say the significant figure for stem is the 3, and it goes all the way up to 89. So it doesn't go up to 90, so I'll stop at 8. So 3, 4, 5, 6, 7, 8. And now let's just fill in the leaves. Well, for all my 30s, all I have is 39. I'll put a 9 down. For all my 40s, well, I have no 40s. I'm not going to put any down, so I'll skip it. 50s, I've got 57, a 57. That looks to be about it, so 2 7s. For my 60s, well, I've got a 65, a 68, 68, and a 63. So I'll put a 3, a 5, an 8, and an 8. For 70s, what do I have for my 70s, guys? I have a 74 and a 77, so I'm going to put down as a 4. Oh, I have a 76. I do have a 70. I have a 70, a 4, a 6, and a 7, not an 8. And for my 80s, we got 82, 85, and 89, and 84. So 82, 4, 5, 9. These are my values, and that's how I create a stem and leaf plot. Guys, if you have questions about this, go to my website, and you'll be able to find these first videos on there. I'm going to put the homework on